So this is my 12 by 12 workspace. It's not much, but it gives me a dry place to work on my projects when the weather's bad outside. So where I live, it's been an unusually warm winter. At the time of this recording, it's early January, and we really haven't seen many below freezing temperatures. And that being said, this little wood stove that I have here is barely able to keep up with keeping it a comfortable temperature, so I think it's about time for an upgrade. I built this wood stove a couple of years ago, and it served its purpose quite well. It keeps a cup of tea warm, and probably keeps it about 10 degrees warmer than it is outside. Now having a wood stove this small does have its drawbacks, because it needs to be tended to often, and also I need to make sure that all the wood I put into it is completely bone dry, because it doesn't generate enough heat for long enough to dry out wetter firewood that I put on top of the coals. So you've served me well for a couple of years now, but I think you're about to be replaced. So while I did say that that wood stove that I have running now does a fine job of heating, that's in 30 to 40 degree temperatures, and where I live it's supposed to get very cold very soon. Hence the need for an upgrade. So I'm going to upgrade my setup to what's called a waste oil heater, and I'll explain them a little bit more in detail in just a minute. But I should be able to build it out of mostly scrap material like what you see before you. So why am I choosing a waste oil furnace to replace my wood stove? Wood stoves are high maintenance, especially one of this size. You can't really put a large enough quantity of fuel in it to make it last more than 30 or 45 minutes between refills. The amount of heat that you get out per the amount of work and attention that you put into a wood stove is much greater than that of a waste oil furnace, and that can be attributed to the liquid fuel. It's much easier to move, much easier to prepare, and overall it takes up less space to store. Now wood stoves are great, and there's nothing wrong with them of course, they're just more time consuming to run. Now in my online research, it seems as though waste oil produced substantially more heat as well for the size of the stove itself. And in my non-insulated workshop, that's kind of what I'm going for. Prepping a wood fire is also time consuming. With a waste oil burner, it's simply a matter of setting a flame to a wick and turning it on. With all of the time saved in starting and tending, a waste oil burner just seems like the way to go. Now waste oil is readily available for me, and that may not be the case for everybody. In some cases, maybe wood is an easier fuel to get, more convenient, or at least not any less convenient. We do all of our own oil changes, so it's somewhat readily available for me. It's also a great way to recycle it. In my case, instead of saving up jugs of used oil that sit around waiting to be taken to recycle, I can sort of recycle them myself. Now before we go any further, some states and areas do have restrictions on burning waste oil, so please check your local laws and regulations before trying to replicate this project. If you do replicate it, I can't be held responsible for any injury or damage associated with the building or usage of it. Sorry, just had to say it. Okay, so the first thing I'm going to do is I want to be able to have a baseline that I can compare the heat output to the waste oil furnace with. So I've got a fire going now, and I'm using small, very well seasoned juniper for my fuel, and I've got just a barbecue thermometer sitting right on top. So right now, with the spacing it is, and it won't be completely accurate because there is a little bit of airspace between this top grate and the actual top surface of the stove, but I'm not out for perfection. So we're at about 175 degrees on top, which is perfect for keeping my tea warm, which of course is the most important reason for a wood stove. So anyway, we'll keep that number in mind and I'll return to it a little bit later. So in all of my YouTube research, I've been able to determine that there are quite a few ways to build a waste oil burner, or waste oil furnace. Same thing. And I've kind of refined it down to two different potential ideas. So I'm going to start with the one here on the left. Basically, you've got a containment vessel, and inside of that containment vessel is a simple cup-like shape, preferably made out of stainless steel or something really heavy to give it as long of a life as possible, but this is where the actual burning takes place. It's sort of a flame holder, if you will. So in this drawing, I'm not really sure why I had the cup up on a post. It just seemed like a good idea to radiate the source of heat from the center of the container as opposed to the bottom. I'm not really sure what kind of contaminants are going to build up in this thing, so having it up there with some space down below for things to collect just seemed like a straightforward plan. It's probably not necessary, but this is how I'm going to build mine. And this design on this side does have a slight downfall in that it needs a source of electricity in order to run. And that's necessity from this fan up here. So this is actually a forced air system. What happens is you have a simple inlet pipe going over and down to the cup in which a fan forces air, and the oil is introduced somewhere up here. It doesn't have to be here as long as they meet up somewhere before the combustion cup, as I'm calling it. I really don't know what it's called. So the oil is introduced here, it runs down this pipe through somewhere on the center of the actual air inlet, and you'd have a valve up here to control the flow, which would in turn control your heat. So the fan would go on, blowing air down into this cup, the oil would be introduced, where on startup it'll meet a flame, which I'm calling the wick, which is just something to start the ignition process, and of course the oil ignites with the help of the air. And also, this is another thing I'd like to mention, I believe this is probably going to be a cleaner burning design than the one I'll show you next, because it's introducing oxygen into the system, which of course will produce more heat, and in theory it'll burn more of the contaminants before they can escape into the atmosphere. So that's really all there is to that. And of course, this is just a containment vessel with some sort of access door to be able to ignite the wick. And you've got a flat surface up here for proper tea setting, and then you've got your exhaust pipe going up, legs to hold it, and it's really a very basic setup. Moving on to the second one. Now I've seen good things about these online, and of course it's a huge pro that you don't need electricity to run it. So the way this one works is you've got some sort of containment vat down here for the oil, followed by a burn tube. Actually, let me get you a little closer. There we go. So you've got the vat down here where the oil sits, and then you've got the burn tube going up, and then you've got a containment vessel up here, which is where the heat interacts with the metal and radiates outward. which is also what these baffles are for. I'm not sure if they really had baffles in some of the online designs, but I chose to add them in this drawing because I think they'd be necessary, otherwise all the heat would just go straight up. But anyway, the oil is just fed through a tube into this vat, and you would ignite this with some sort of accelerant, maybe some gas diesel mix, safely of course, to get the oil up to a flash point, which will start to vaporize, and that vapor is flammable, which will create an updraft, putting oxygen into the equation through these holes, which supports ignition, and then the heat would atomize more oil, and the process sustains. Now I have my concerns for safety in this design. It would be nice not having to run any sort of power to it, but having open flame that could potentially creep out of these tubes, or perhaps if it's not running in the time in between, something could build up in there, creating a fire, and I just don't like having exposed flame, as I just said with an open wood stove. But anyway, I think for my preference and the idea of simplicity, I think I'll be going with this design right here. Now, as I said, most of the parts can be made from recycled materials. For the fan, I'll be taking the guts out of this blow dryer. The main containment vessel will be this helium can, which is another upside. I think I can get more heat in total for a smaller package. This should be about the total size of the whole thing, not including exhaust, of course, and the air inlet and the legs and so on and so forth. But this is going to be my main body. It's not terribly thick, so I don't know how it'll hold up over time, but they're so simple to build, I could always upgrade it to a thicker walled propane tank later on. For proper T setting, we're going to need some sort of sheet metal to skin over the top of this, and that's where I've got this from. It's just left over from an old project, and it's just some 1/8 inch sheet metal. So for the blower, I'm going to take apart this old blow dryer. Now these are readily available for super cheap at any thrift store you go to, and they all contain a high volume electric fan, and that's what we're after. I'll take that apart and then I'll give you a little more information on this. So fun fact on these motors, while the blow dryer itself is actually 120 volt AC, these fans run at anywhere between 6 to 24 volts DC. And so what they do is they actually put the fan in series after the nichrome heating elements, and that heating element acts as a giant resistor, of course, that's its job, which drops the voltage down to, like I said, between 6 to 24 volts, but it's still AC, and this is a DC motor. So on top of the motor there, you can see 4 diodes arranged in a bridge rectifier to convert it to DC, so that's something to consider. Here's a less obscured view of that bridge rectifier. So the outer diameter of my fan is about 2.5 inches. And this of course depends on the model of your blow dryer, and it's something that you'll change depending on what you have to work with in your final design. Okay, the first structural thing I'm going to tackle is the containment vessel. So for this, like I said, I'm using a helium tank, and helium is desirable because it's of course inert and it won't risk any ignitions or explosions. So this is a spent tank. The valve is currently in all the way open position. And so the next thing I'm going to do is mark a circle all the way around to give me a line to follow to cut, and then I'll go from there. You've got a plasma cutter, now's the time to use it. Temperature update, 200 degrees. So, you know what really sucks? If you answered spending 5 days on a project, getting over an hour of footage of the build process and being quite proud of the end product, and then losing said footage because the SD card got corrupted, then you would be correct. So yeah, I'm pretty bummed out. I had some pretty good quality footage put together full of lots of funny jokes and really something I was proud of, and then I went to go put it into my computer and importing failed, and unfortunately I lost everything I had except for what you've already seen. But that's the way the cookie crumbles, and I think I can give you a pretty good idea still of how it works. Oh man, I don't even know where to begin. I guess to hopefully make it somewhat understandable, I'll just go in the order that I made it in. So I started off with this. This is the top plate. I wanted to be able to have a flat surface on top that I could use to put tea on, of course. So I consolidated all of my inputs and outputs over to this side. So this plate itself is made of a piece of 1/8 inch sheet metal, nothing too fancy. Now these bands across here are made of 2 inch by 1/8 inch flat bar, and that 2 inch by 1/8 inch flat bar was cut into pieces that was the same diameter as both the outside of my containment vessel here and the inside of the containment vessel, bent around in circles and welded together in a continuous ring. And then those rings were welded onto this top plate. Now the outer one was put on first, simply by lining up the edge of this and the edge of this, welded around, and then what I decided to do is take a ring of material from this top piece that I took off of this, and I placed it in this gap in between the 2 rings to give even spacing, and then welded the inner ring in place along the sheet metal. And that's really as complicated as the top plates get. And my original plan was to put gasket material on the inside of this, but I don't think it's entirely necessary, and it's also quite difficult to find fiberglass rope that's small enough to fit into that gap. So because I'm very confident in the seal between these two and the tank in between, between, I am not going to go with that option. Moving on now to the air intake. This is a piece of 2.5-inch metal pipe that I had lying around in my scrap metal, and that just so happens to fit perfectly with the outside diameter of the fan we'll be using, and that'll be attached in place with some wood stove pipe sealing tape. Very high temperature, not that that's a concern, because hopefully this will move enough cold air over itself to keep it cool enough to not melt. Now, I decided to give the air a small run before it was reduced down, so I created this, which is about a 4-inch long piece of that same tubing, and then that's necked down by a washer here. Now that washer isn't just a flat washer anymore. What I did is I took a washer with the same outer diameter as this piece of tubing and a 1-inch internal diameter, and I heated it up, set it on top of this spare piece of tubing that I had left over as a form, and then I used this piece of 1-inch water pipe, put it in the middle. Of course, since the washer was heated and red hot and malleable, I put this in the center, hammered it with some force, drove this down, and created a dip in the center of the washer, created a nice cone. That cone was then welded onto here, this was put in place, and then welded onto this, which is a piece of 1.25-inch tubing, and that 1.25-inch tubing, of course, carries air down to the top of this. Now, keep these angles as shallow as you can, just to minimize the resistance to airflow. So that goes down and goes through here, and while I'm here, I'm going to point out how I made this hole. I don't actually have a hole saw or a plasma cutter available to cut a circular hole to fit this through, so what I did instead is I used an 1/8-inch drill bit, and I drilled holes around in a circle in the same diameter as the outside of this pipe. And then I took a screwdriver and knocked out the in-between bits of metal between the holes and punched that center part out, and that of course gave me a hole big enough for this. For this tubing, it has an outside diameter of a 1/2 inch, and luckily I do have a 1/2-inch drill bit, so I simply drilled that hole and put the oil tube through. As we move down to the parts where nobody can see, you can see the welds get remarkably worse. What happens is that tube comes down in a 45, and then down in another 45 to the center, or being equidistant from the edges of the tank, but just try to get it as close as you can. Now the oil tube comes in down through the middle, but does not enter the air tube yet. And the reason for that is, again, I wanted to minimize any restrictions to this airflow that I could, which, this being a 1/2-inch water pipe, I reduced it down to a piece of just 1/4-inch tubing to further reduce the footprint in the end of the pipe. Now that's just cut off flush, as you can see, and leading straight down, the air and fuel mix will be pushed down to the center of this cup. Now I'm leaving about a 2-inch gap between it and the cup because it looked right, and that's probably good enough for this kind of engineering. So as I said, this was cut out from the bottom of a fire extinguisher, turned over, and then welded on for my cup. And it's about 3/8 of an inch thick, and I think this will probably outlast the whole unit. So this is a lot shallower than the cups you've probably seen on some of the oil burners online if you've looked at them before, and here's my reasoning behind that. What happens is, as the air goes down, it's going to get deflected at whatever angle these are, and if it was a steep cup, it would direct most of that heat back up, and I thought I could get a better effective use of the heat by making it contact the sidewalls of the tank as long as it can. So with the shallow angle, I'm hoping it'll come out and up at a shallower angle and have more interaction time to transfer that heat to the metal as it goes up, and of course leaves out the exhaust. Now this exhaust is also made from 2-inch flat bar. I didn't have any tubing the right size, so I did the math, got the length of this, and welded it in place. Now this is big enough that I could cut out that hole with my angle grinder, and that was the end of that. Now as I said, this is the oil tube, and this is what carries oil down to drip into the pan. It's made out of 1/4-inch water pipe. So as far as the actual construction, everything is pretty flexible. You can do it any way you want, as long as you stick to something safe and it's functionally the same, where you have oil and air being introduced into a pan where it burns inside of a contained vessel and then gets exhausted. This is just the way I chose to do it. So as I said, that friction fits in between the inner and outer ring that's welded up to this top plate, and that was originally going to be removable, but I had a change of plan through the video, which of course I explained and then lost. But I'll go over all the changes I decided to make in the final design as soon as I finish explaining the frame. Now the frame I built is just made out of 1.5-inch by 8-inch angle iron that you can see I welded into an 18-inch by 18-inch square, and then simply came up from each corner to this outer ring, welded it in place, and I think it's good and stable. Now I wanted a pretty big footprint, because when you're dealing with anything that involves flame or especially flammable liquids, or is generally just hot, like a heater for example, you don't want it tipping over, and so I wanted a good wide footprint and lots of support because I didn't want to have any risks. Now I also have a lot of future plans for this furnace. I'd like to add some additions on, maybe even some really different stuff, maybe some steam power or a coffee maker. I don't know, we'll see what the future holds. But I wanted to leave those possibilities open, so I have all these flat surfaces here. I can bridge these gaps and use these for attachment points to put whatever I want on this thing. So that was the reasoning behind my frame, but this is probably the most flexible part of the whole build. It doesn't really matter as long as you have something that safely and securely holds it in place, keeps it a safe distance from the ground, and anything that could be from side to side. So now on to the changes and plans that I made. So this is no longer going to be removable, or at least not in an expedient way. I'm going to simply force this tank as far as I can into this top piece, drill 2 holes in between each set of supports, and then pop rivet this in place. And those pop rivets will be easy to remove later on. I can grind the ends off and then use a punch to punch them inwards, and then I can remove the tank and replace it if necessary. That being said, that changes the way I'm going to ignite it. Now to ignite it, you have to first introduce a flame into the burning cup. There's a wick, for example, so you turn on the oil, let it fill up a little bit, put something in there like a piece of cloth or paper towel, light it on fire, and that would absorb the oil to create a flame. Then you turn the oxygen on, and so on and so forth. But since I won't have access to it directly, that'll have to change. So here's what I'm doing instead. So this is a 2" by 1/8" galvanized pipe nipple with a 2" cap threaded on top. And this is what I'll be using for the port to access to the top. Now, I know what you're thinking. Galvanized pipe should never be welded, and you are absolutely correct. There are certain circumstances in which it's okay. Now, I'm quite concerned over welding this stuff, and so I have the advice of somebody who owns a machine shop and has 30 years of welding experience under their belt. They suggested that while wearing a mask, I sanded off the galvanized coating on the outside, which I did over there, outside of my door in a very well ventilated area, and we're sure to breathe in no dust. So after doing that, of course, I've got a clean welding surface here, and I don't have to worry as much about the zinc oxide on that specific part. Now, of course, all of the threads on top and the inside are still galvanized, so I've devised a plan to do this as safely as I can. I don't have to any 2" black iron pipe or black steel pipe, so this is kind of what I'm forced to do. I'm going to take this piece that I cut off, and it doesn't really need to be any specific length, and I'm going to heat it up. In fact, I'll do that right now. So I'm going to take this piece of pipe and I'll put it right in there in the coals, and of course that's going to give off lots of zinc oxide gas and toxic fumes that I don't really want to breathe. But in there, all the gases will get drawn up with the smoke and go out into the atmosphere. So this only needs to get to about 200 degrees to get all of that stuff baked off, but we're going to push that limit quite a lot just to make sure that we're as safe as possible. This wood stove has no idea it's helping to seal its own fate. Shh. So I severely apologize for not being able to show you the detailed build process, but I hope you got a good idea of how it works and how it went together. Dang it, I had so many funny jokes too. Also, in case I didn't mention, I definitely did not beat the cold weather. So now I'll do the same thing I did to that end bit to the cap itself. I like to cook my plumbing parts at about 1,000 degrees for 45 minutes. Okay, we're all riveted together, so we're getting really close to being able to actually try it out. First we need to add our fan. Now on the side of the motor it'll tell you what the voltage is, and it's slightly obscured with plastic, but in this case mine is a 24 volt DC fan. Now it's already got a bridge rectifier on the back, and that'll convert the alternating current to direct current. And so to get that 24 volts, what I'm going to do is I'm going to use this transformer. Now these 120 volt AC to 24 volt AC transformers are relatively easy to find. I believe they're used in automatic sprinkler systems. Also, I believe some doorbell systems use them. So in this case, I'm going to be hooking this up straight into the bridge rectifier, and we should be able to spin up our fan without having to rely on batteries. Okay, so I've got my fan mounted with my overly priced sticky tinfoil, and you can see that it's not actually oriented in the same direction that it was in the blow dryer. This would have been towards the front of the blow dryer, and this would have been towards the back. So in its standard configuration, as if it was still in the blow dryer, it would be pulling air from the furnace, and of course that's not ideal. So I turn the bridge rectifier around. Now for an oil reservoir, this is what I'm going to be using. It's an old 5-gallon sodium hydroxide container that was used at a water treatment plant. Now it's been thoroughly cleaned, of course. The reason why I'm going with this is because it's very convenient, because the handle on it can be easily moved and refilled and dealt with, and it has a cap on it that can readily accept 3/4 inch pipe thread. So right now I have threaded in there a 3/4 inch pipe nipple and a 3/4 inch gate valve. And the reason I'm going with a gate valve is because a gate valve has no rubber parts or gaskets. It's completely brass on brass. Now oil is pretty hard on rubber, and so I don't need to worry about any gaskets being eaten out, and I can easily use this to control the flow of oil. So with that being said, I think we're completed. We've got oil in, we've got air in, we've got a container that's sealed, we've got an exhaust, we've got a way to ignite it, and we've got power and a frame to hold it all together. So now the only thing left to do is a test. Unfortunately, it's dark out right now, so it'll have to wait till the morning. Now it's time to address an important question that I'm sure you've all been thinking this entire time while I'm building it. And why didn't I sand all the paint off of this? Well, instead of doing that, it would take a lot of time and resources, so what I'm going to do instead is take this outside for testing in a very well ventilated area, heat it up as much as it can, and just burn everything off. I've built barbecues before, and that's always the best way to go. And then after that, you can simply wipe it down with some steel wool or a scotch pad or a wire brush or whatever you have, and it'll offer the nice bare metal surface. So that's, I think, all for tonight. Now for me it'll be overnight, but for you guys, I love editing. So here we are, we've got the whole setup going. We've got the oil up here set up on our stand. We've got a line running down to here into our unit. Then of course we've got the transformer, which is protected by plastic right now because of how much it's raining. We've got the unit itself here, and I've got some stovepipes sticking on it now so we can get a better idea of how it's gonna run when it's actually connected and inside of my shop. So as far as the startup process goes, we've got the cap off now. And if you can see down in there, you'll have to take my word for it since you really can't. But I've turned the valve on over there at the oil reservoir, and I've let a little bit of oil go into the burn cup down there to prepare for us to ignite it. So the cup is full of oil. Let's shut the valve back off. Next thing we're going to do is insert our flame. So here's how this is going to work. I've got my wire handle here that I just bent up out of some baling wire, and then a piece of rag soaked in oil. This is going to be my wick to start the whole process. I'm going to ignite this on the outside, put it in, set it in place, and then turn the air on. Okay, that's in place. Now we're going to turn the air on. You see we've got some flame going down in there now. And we've got some smoke starting to come out of the chimney. Good signs. And obviously at this point you'd want to turn your oil back on to start feeding the fire. So I decided to let this run for about an hour just to get an estimation of how much oil it uses per hour. And I've got that tank marked so I can see exactly how much it's used, and I'll go over that in just a second. So this thing works pretty well. You can see I've got the thermometer on it. It's been on there for about 5 minutes now, and we're already up to about 350 degrees. So this is getting much, much hotter than my old little wood stove. As a matter of fact, you can see where it's starting to blue the metal up on top of here. So this is definitely not done rising yet. I can take this cap off and show you what it looks like down on the interior. It's burning hot, and I love that I don't have to do any maintenance on it, and that oil will last me at least a full day. You see that paint is coming off just that I had anticipated. Eventually, once this is all done and cooled off, I'll take my wire wheel to that, and of course I'll wear a dust mask because I don't want to breathe any of this, and I'll get it all down to bare metal. One thing I'd like to mention with removing that galvanized coating on this, there has been no yellow peeling at all. So I know I got all that zinc off of this, and that's pretty comforting, so that is a valid method. One thing I was pleased to see is how clean the smoke is coming out of this, and that's what I was hoping to accomplish by going with the design with the forced air. With that forced air, I'm able to get this flame a lot hotter, and thus I'm able to burn off a lot more of the impurities. One thing that I'm going to take away from this is maybe using a quieter blower. This is going to be a little annoying in the shop. Checking back into a thermometer, we can see it's just risen over 400 degrees, so I'm curious to see where it'll stop. So I'm quite pleased with this. For such a small package, it's working quite well. There's really not a lot of places you can go wrong with a waste oil heater. The concepts are simple. As long as you stick to the principles, you won't have any issues. So at the beginning of the hour, this black mark up here was where the oil level was. And you can see in about an hour, we've only dropped by about a ½ inch. Now, one thing that's a pleasant surprise is even though this is already up to about 475, just in the time it took me to move over here, all of these pipes are still cold. Not cool, but cold. I can touch all the way up to here, and I'm sure the rain is having something to do with it as it's landing, evaporating, taking some of that heat away. But that's the case nonetheless here and here. I wish I had an infrared thermometer to prove this to you guys, but you'll have to take my word for it. I think I'm gonna call it Sputnik. I don't know if you can see that or not, but we're actually starting to glow red on the bottom of our containment vessel here, and that's kind of what I was hoping for. I'm not sure how well you can tell on camera, but you can see the way the flames are being deflected sideways instead of straight up, and that's attributed to the cup design. It's going over shallower edges instead of those steep ridges. So the heat is interacting with the sides more than it's interacting with the top, just as I had hoped. Ooh, that's hot. We made it to 525, and I haven't seen it move since, but this is definitely way better than my little wood stove. So to shut it off, all you need to do is shut off the air and the oil, and then of course you won't have any oxygen or fuel to burn. You know, I'm gonna say it, I'm honestly really surprised with how well this thing works. I'm pretty happy about it. I mean, I've got something that I can use to heat my shop that I don't need to put nearly as much time into, and that produces more energy for about the same amount of work that it took to build a wood stove, if not less. So now a couple of things that are unrelated to the project. So I'm sorry that this took so long to upload. I actually had a 3-day retreat that I needed to go on, and I had a few setbacks that resulted in some delays. And then of course I definitely apologize for losing that build footage. Still pretty salty about that one. And also, if you've kept up with my channel, I've had a huge explosion in subscribers and views lately, and I've actually been pushed over the mark to be monetized now, and I'd like to thank all of you guys so much for that. Honestly, it means a lot because I'd like to keep doing this, and I didn't expect to reach this goal so soon. And also the comments on the videos have been immensely supportive, and they kind of keep me going when I need to find motivation. So you guys feel free, please, to offer suggestions. Quite a few of you guys did, and you had some pretty good ideas. So I guess overall, I'd just like to thank you guys for your kindness and for your support. Hopefully I'll be a little more regular with build projects now, and I've got a comfortable place to work thanks to this. But anyway, one more huge thank you to everyone watching this video, and thank you to the subscribers of the channel and just people who are generally being really supportive. We've got a lot more things in the works, so if you'd like to see more projects like this and even some more impractical ones, which I have quite a few ideas for, then please consider subscribing to the channel, liking the video, and if you know somebody who'd be interested in this, sharing it is a great way to help me out as it gives my videos more exposure, and you'll be sharing it with somebody who might be able to gain something out of it. So with all that being said, thank you guys again so much for watching. Until next time. So here it is in its final resting place. I can hear all the questions now. Is it gonna blow up?